Hello. Hello, Ryan. Welcome.
Hello.
Yeah, Ruby is there too. It's good to see you are here. Anna Jung, welcome. I'll move straight to what we have to do today. Let me see what I have here. Yesterday's homework, what happened? I see only 2 people have submitted, Ryan and Bill. Why haven't you submitted your homework, Anna?
I will submit it in after the weekend because it's difficult.
The integration topic is difficult?
Yes.
The substitution, I think you are just lazy, you know.
But I'm not. It's just difficult for me.
Why haven't you submitted Shan Chen Yi? Shanti, why haven't you submitted your homework? Is she there?
Are you asking me?
Yeah. I called your name, right? Yesterday's work has not been submitted yet.
Yeah, because I think it's too difficult and I haven't finished all.
Okay. You will have more work to do today, remember. Okay. Okay. We will talk today about reduction formulae. We will use what we talked about yesterday. We will use the idea of integration by parts. So I got this question from your P3 mathematics book so that we can use it to review integration by parts. Can you guys just take a few minutes to solve this problem? It says the diagram shows the curve y equal x cubed natural log of x and its minimum point M. You are asked to find the exact coordinates of the point M. And then you are asked to find the area of the shaded region bounded by this curve, the x-axis, and the line x equal 2. You guys should take 2 minutes to try the problem. Done? So for the first part, you have to differentiate, right? dy dx should give you x cubed times 1 over x plus 3x squared natural log of x, right? Which should be x squared plus 3x squared natural log of x, which should be x squared times 1 plus 3 natural log of x. If this is equal to 0, then x is equal to 0, or 1 plus 3 log x is equal to 0, right? This means ln x should be equal to, how is that possible? Negative 1 over 3. Did I make a mistake somewhere? No, I didn't make a mistake somewhere. So x should be equal to e raised to power negative 1 over 3. No. So that's the exact coordinate. X equals 0 is the maximum point, and x equal e raised to power negative this should be the minimum point, because that's the only point that is after 0, right? And then we are asked to find the exact area of the shaded region. This shaded region, we need to first find this point. What am I doing? So we need to first find this point, right? When x cubed in x is equal to 0, that is when ln x is equal to 0. That gives you x equal 1. So this point is 1, right? So it means that we need to integrate. So the area should be the integral from 1 to 2 of x cubed ln x dx, right? This is the reason, main reason I gave this question today for you to look at. To integrate that, what should you do? You have to use integration by parts. And what should you choose for your u? Integration by parts says that the integral of uv prime dx is equal to uv minus integral of v u prime dx. So what should we choose for our u? Something that we can differentiate, and it will make the problem simpler. So I would choose natural log of x as u. U is ln x. So u prime du dx will be 1 over x. dv dx x cubed. V should be x raised to the power 4 over 4, right? So this means that our area will be integral from 1 to 2. Did I put integral? Should be uv. first. So x raised to the power 4, natural log of x over 4 from 1 to 2 minus integral of vu prime of x raised to the power 4 over 4 times 1 over x dx, right? And this part will now simplify to integral from 1 to 2 of x cubed over 4 dx, which is x raised to the power 4 over 16 from 1 to 2. So you just substitute the 1 and 2 in it. That's not something I should be doing. Okay. So we have used integration by parts to solve that problem. Now, can you look at this one? You guys should try this one for 1 minute. We are asked to find I equal that integral of e raised to the power x sine x. You also have to use integration by parts here. Aha. Let me just write down the integration by parts formula again. Integral of u v prime equal uv minus integral of v u prime. This formula is in the formula sheet, huh? So if you ever forgot, it doesn't hurt to check. Here it is. In case you ever forget. So in the exam, they will be testing you on your ability to use it, not on your ability to remember it. How to use it. So what should you choose for your u and your v prime here? For this one, we choose our u, our v prime to be something we can easily integrate. I see from here, I can easily integrate e raised to the power x, right? Even though I can also easily integrate sine x, but it's more easy for me to integrate e raised to the power x. So I'll choose my u to be e raised to the power x. And so my u, no, what did I do? I'll choose my u to be sine x, since I can differentiate this quicker. So u prime will be cos x. I'll choose my v prime to be e raised to the power x because I can very quickly integrate this. So v will be e raised to the power x. So I will be what? uv e raised to the power x sine x minus integral of e raised to the power x cos x dx. Now ask yourself, does it make the problem? Does it solve the problem? No, still does not solve the problem. I will use integration by parts again for this one. I'll use integration by parts one more time and see what happens. So again, I'll choose my u to be cos You can choose your u to be e raised to the power x or cos x. It doesn't matter which one you choose here. Let me choose it to be e raised to the power x and c. And then my u prime, e raised to the power x. The reason I choose this is maybe I didn't make a good choice here, so I want to reverse the choice and see what happens. And then v prime is cos x. V is what? Sine x. You see, it looks like I'm going back to the original problem, right? So now, this integral will be uv, which is e raised to the power x sine x minus minus integral of e raised to the power x sine x dx. This is not going to help me because e raised to the power x sine x will cancel out with this one, and it's not going to, everything will give me 0. So I'll come back here and make the choice again. So it looks like my original choice of u to be cos x was all right. So u prime will be negative sine x. And then v prime e raised to the power x, v is e raised to the power x. So my integral will be e raised to the power x cos x minus integral of negative sine x times e raised to the power x dx. That gives me e raised to the power x cos x plus integral of e raised to the power x sine x dx, right? That gives me e raised to the power x. I'll leave it there as this, and then I will come back and substitute everything in I now. So my I becomes e raised to the power x sine x minus e raised to the power x cos x minus again integral of e raised to the power x sine x dx. Does that solve our problem? Can you guys look at it carefully and tell me what's the problem here? If there is a problem. Is it going to solve our problem? Yes. This part here, integral of e raised to the power x sine x, is what we started with, right? So this is I again, right? So I'll write it as I. And then now, this means that I is equal to, I'll factor out e raised to the power x there, e raised to the power x into sine x minus cos x minus I. And then I can send the I on this side. So 2I will be e raised to the power x into sine x minus cos x. That gives me I to be equal to e raised to the power x over 2 times sine x minus cos x. So I have solved the problem. This gives us a good example of what we shall, of how to get a reduction formula. This technique can be used to integrate a function like cos squared x, cos cubed x, cos raised to the power 4x, and so on. So if I'm asked to integrate, say, cos square x, this is the same as integral of cos x times cos x dx, right? So call this one I. So you can choose your u to be cos x, one of the cos x. U prime will be negative sine x. Choose your v prime to be another cos x. V will be sine x. So your integral becomes uv sine x cos x minus integral of negative sine squared x dx, because you have sine x there. So it is sine x cos x plus integral of sine squared x dx. Now we need to change this to something like cos squared x so that we can put it as I. Sine squared x is 1 minus cos squared x. So this, our I, becomes sine x cos x plus integral of 1 will be x plus minus integral of cos squared x dx. And this one here is I. So you can send the I this way. That will give you 2I should be x plus sine x cos x. So I will be x plus sine x cos x over 2. Is that a reduction formula? Still no, that's not a reduction formula. But that will lead us to, it helps us to understand how to find reduction formula. What is this? We are asked to evaluate this one now. We have already looked for cos squared x. Now we need to look for a general formula to look for cos raised to the power nx. This is the same as integral of, we will separate it into two parts, cos raised to the power n minus 1x times cos x dx. Let's call, yeah, that is in. We are not calling it, it is already given as in. So what we just solved here should be I2. After we find a general way to integrate in, then we can use I2 and see that we will get that value we had there. So we separate it into two parts like that. And then we choose one part to be U and another part to be V prime. V prime. So you let your U be cos raised to power n minus 1 x. We have to choose U to be this. You cannot choose U to be cos x because you will not be able to integrate cos raised to the power n minus 1 x. So you have to choose U such that you can, some function that you can integrate, you can differentiate, okay? And then choose V prime, some function that you can integrate, okay? So the technical point is always on V prime. You have to always choose V prime to be something that you can integrate, okay? And then your U becomes the other function. So U prime here, we can differentiate that. That will give us what? You differentiate the inside. Let's first differentiate. This is a product. Let me just write it down somewhere. That is the same as cos x raised to the power n minus 1. And when you have to differentiate this, you first differentiate the outside. That will be n minus 1 times cos x raised to the power n minus 2, correct? And then you differentiate the inside, you'll get negative sine x. So that is, I said it's a product, it's a function of a function. So that's a chain rule. So this gives us negative n minus 1 times cos x, cos raised to the power n minus 2x sine x, right? And when we now integrate cos x, we get V to be sine x. So this means that our in will be uv, which is cos raised to the power n minus 1 x times sine x minus integral of this, of negative n minus 1 cos raised to the power n minus 2 cos raised to the power n minus 2 x sine squared x dx, correct? That is the same as cos raised to the power n minus 1 x sine x plus n minus 1 integral of cos raised to the power n minus 2 x. Sine squared x is the same as 1 minus cos squared x dx, right? This gives us cos raised to the power n minus 1 x sine x plus n minus 1 times, the first integral will be integral of cos raised to the power n minus 2 x cos raised to the power n minus 2x dx. And then the second integral will give us negative n minus 1 times integral of cos squared x times cos raised to the power n minus 2x is just cos raised to the power n x dx, right? When you multiply this by that, you should get this, right? And this one multiplied by that gives us this, right? I hope you guys are getting what I'm doing here. So this gives our IN. Before I write our IN, you will recognize that this one is integral of cos raised to the power n minus 1. So we can call this IN minus 2, right? Integral IN was integral of cos raised to the power n. So integral of cos raised to the power n minus 2 will be IN minus 2. And this one, integral of cos raised to the power n, is IN, right? So we can send our IN here. So we'll have IN plus n minus 1 IN. Should just be this, right? Should be cos raised to the power n minus 1 x sine x plus n minus 1 times IN minus 2. So this is the same as NIN. Should be that. So your IN should be cos raised to the power n minus 1 x sine x plus n minus 1 IN minus 2. You can divide this by n here and divide this also by n. So IN is cos raised to the power n minus 1 x sine x over n plus n minus 1 over n IN minus 2. So if you have, this is what we call a reduction formula for cos x. Reduction formula for integral of cos x. So if you want to find, say, integral, let's check by looking for integral of cos squared x dx. That is I2. I2 will be cos x sine x over 2 plus 1 over 2 I1. And I1 is integral of cos x dx, which is sine x. Which is sine x. So this will be half sine x. And now what we will have here is hope I didn't make a mistake somewhere. Anyway, we can use that to find integral of cos raised to the power any power. Our reduction formula. If you are asked now to look for, say, integral of cos raised to the power 5x dx, that will be I5. And then you simply put 5 for n, and then in minus 2 will be I3, and I3 will be integral of cos raised to the power 3. And then you will use the reduction formula again to look for I3 until you reduce it to something that you can integrate directly. So it will reduce to cos squared or cos only. The reduction formula can also be used for a function like this one. In is integral of x raised to the power n e raised to the power x. You can use the same method. Your u is x raised to the power n, for instance. I think for this one, you can still choose your v prime to be x raised to the power n. It's fine. So, but I choose to use it like this because I can easily integrate e raised to the power x. So the u prime should be n x raised to the power n minus 1. V prime is e raised to the power x. V will be e raised to the power x. And then your I becomes uv xin is x raised to the power n e raised to the power x minus n times integral of x raised to the power n minus. So this is where I was. Your in is that n x raised to the power n minus 1 e raised to the power x dx. And this quantity here, this is in minus 1, right? So that gives us a reduction formula, right? So in is x raised to the power n e raised to the power x minus n minus 1. So this is a reduction formula. For any value of n, if you have x cubed, you can just put your n equals 3 here, and this will be integral of x squared that. Hang on, please. I will solve two more examples, and then I will try this video. Can I have up to 2? I have like, we have like how many minutes left? We have just 10 minutes left. If you are asked to say integrate, this problem is in your book, so maybe I don't need to solve it. It is in your book, it's an example in your books. So I just need to explain how it's done again. So we have I4 there. We can take this to be the same as integral from 0 to pi over 6 of tan raised to the power 3x times tan x dx. And then you take your u to be tan raised to the power 3x. U prime will be will that solve our problem? Maybe not. This will not work. This can be integral of tan squared x dx. Why did I say the tan? Why was the previous one? I had tan raised to the power 3x times tan x. I said it may not work. Why? Because if I take this as v prime, I still cannot integrate that, right? I can differentiate this. I'll get sec squared 3 tan squared x times sec squared x, and it will not help us in any way. So a better way for me to do is to put it as tan squared times tan squared. And I know that one of these tan squares is the same as 1 minus sec squared x. That will be easier for me to work on. Right? So you have to always try many different ways to work on the problem. The solution is in your book, so I will not belabor this. Besides, I don't have much time, so is there another problem to look at? Let me look at what is in the book. There are many problems in the book like that. So maybe we should look at exercise 22b. We look at one problem. Maybe we should look at question 2, for instance. So I6 is that. We're asked to find a relationship between I6 and I4. We have already solved this problem. This is our IN. Here is IN. So you can do it again. But for me, there's no need to do it again. I'll just come and paste it here. I already have my IN there. That is my IN. Next, I have to look for IN minus 1. IN minus, oh, no. What am I doing? From here, you can look for I6. I6 will be x raised to the power 6, e raised to the power x, minus 6 I5, right? And I5 is x raised to the power 5, e raised to the power x, minus 5 I4, right? So that is the relationship they ask you to look for. You simply take this one and substitute here. So this means that I6 will be x raised to the power 6, e raised to the power x, minus 6 times x raised to the power 5, e raised to the power x, minus 6 times 5, plus now 6 times 5, 30 I4. That is the relationship you are asked to look for. You can simplify that. So that will just be negative 5. Why? No, it's not negative 5. Because here is x raised to the power 5. You can factor out x raised to the power 5, e raised to the power x. So x raised to the power 5, e raised to the power x, times x, e raised to the power, times x, no e raised to the power, x minus 6, times x minus 6 plus 30 I4. This one that you guys are not stopping me somewhere. I hope that you are all understanding, and I also hope that I'm not making any mistakes here. Did anybody find a mistake? Anna John?
No.
Are you following me? Are you understanding what I'm doing there?
Yes. Understand.
Will you solve the problems? All of these?
Maybe.
Will you solve these problems, all of them? And submit this weekend by Sunday.
Okay.
And another thing is this. You guys, you've not been, when I looked at this course, only one person has signed up. Only, I think it's Ryan. I need you guys to watch videos of many different teachers explaining the same things in many different ways and then get good understanding, okay? Just reading the book does not help so much. Only Ryan has signed up for this course. You need to, why I spend so much time building these courses with so many videos is because I need you guys to be able to watch how other teachers are working on these problems as well, or on similar problems. And sometimes there are some things new, some other new problems, new ways to solve other problems and so on. I also put For example, I also put the past paper solutions here from other teachers. Since we don't have time to go through past papers, so you can see exactly the kind of questions that will come in the examination. So make sure you sign up for this course today. You will have to study lesson 1, lesson 2, and lesson 3. Okay? Okay, Anna, jump.
Okay.
Okay, Shanti.
Yes.
Okay, Ruby. Brian is already. Okay, Ruby. I need to see your name on this call by today, okay? Is Ruby there? Ruby says no. Ruby. She has refused to talk. I need to see your name on this course. Here, you too. That is it. So I'll talk to you guys again next week. If you have any problem, don't forget to contact me, okay? Contact me and I can solve your problems. Like maybe you have problems working online, I can always help you with some technical problems. All right? Okay, see you guys.